The history of antimatter begins in 1928 when Paul Dirac wrote an equation that implied the existence of antiparticles, the building blocks of antimatter. The scientific community was astonished until the first proof of their existence in 1932 when Carl Anderson observed the track of an anti-electron that he called positron. It wasn't until after the invention of particle accelerators 22 years later that the antiproton was observed by a team of physicists led by Emilio Segre and Owen Chamberlain at the Bevatron in Berkeley. Working with them was Tom Ypsilantis, then a young postdoctoral student.
We selected out the slow particles. We were able to measure their momentum and their velocity, and we were able to measure the mass. And so we found the mass exactly of the proton, but it was negatively charged, so it had all the properties of an antiparticle. I mean, for me, it was just one more example of the fact that we can understand nature.
In 1955, a second team at the Bevatron announced the discovery of the antineutron. All three particles that make up atoms, electrons, protons, and neutrons, were now known to each have an antiparticle. The observation of a nucleus of antimatter in 1965 confirmed the symmetry between matter and antimatter, which was further proved in 1995 when the first full atoms of antimatter were finally synthesized in the Lear accelerator at CERN.
Why antihydrogen at CERN? We had the basic ingredients of these atoms of antimatter, of antihydrogen. But the real process was still to be put in action. One of the best machines for this was the Lear machine, the low-energy antiproton ring, where antiproton beams of large intensity were circulating over and over for many, many days. What is the reason why the antihydrogen or the antimatter are not in our universe? My real hope is that antihydrogen can be used for understanding this question.
Antiparticles soon gained an important role in the game of high-energy physics. Accelerators evolved into particle-antiparticle colliders, increasing the energy available for further particle production. In 1960, Bruno Toucek proposed the first electron-positron collider in Frascati, whereas protons and antiprotons, after overcoming many technical difficulties, collided for the first time at the CERN SPS in 1981. The future reserves more challenges. Very soon a new antimatter machine will be operational at CERN. The antiproton decelerator will help physicists with the scientific challenge of creating and containing antimatter.